Okay, so today last time we talked about local minimum. Well, last week we talked about local minimum, local maximum, increasing, decreasing intervals, and then we talked about first and second derivative tests. So today we're going to use these concepts to find some um, what's called optimization, to solve some optimization problems, which is basically finding the maximum or minimum of a function. So last time we talked about what's a relative maximum, relative minimum, and we talked also, I think, of at some point about global maximum or global minimum. So in your book, it's called absolute maximum or minimum. So we say, let me just write that down. So we say that the function f has an absolute maximum uh, or minimum at x naught if the value of the function, so f at x naught, is, so it's a maximum, so it's going to be greater than or equal than at any other point. Right, so for any other x, we have that the value at that particular x is less than the absolute maximum, and so minimum is the same thing, so I'm just going to write it in the parentheses here. F at x naught is going to be less than or equal than fx. So again, for any x. Okay, so that's the meaning of absolute maximum and absolute minimum. Okay, and so sometimes what we're really interested is finding the maximum value or minimum value of something. So maximum value, absolute maximum value is that number there, is fx naught, right? So that if you find the x naught, so where you have absolute maximum, so we say absolute maximum value, right, is that number fx naught, such that this condition holds. Okay, so that's called, that number there, this number here is called the absolute maximum value, and absolute minimum value, we can also do minimum here, and that would be, so the absolute minimum value would be this particular thing. Okay, so where you have the smallest thing. So how do you find absolute maximum or absolute minimum? Okay, so a lot of the times they are asking you to find it on some interval. So, well, sometimes they may say that they specify an interval, or sometimes they may not specify an interval. So we will look at the examples, and depending on the examples, we'll try to do this. So let's do this example. Oops. This example from the homework. This is number 1. So here it says, you are given a graph of a function f defined on this interval from -5 to 5, and you need to find the coordinates of the absolute maximum. So coordinates of the absolute maximum and the absolute minimum of this function if they exist. Okay, so just looking at the function, it's clear what are the points where I have absolute maximum and absolute minimum. This here is the point where I have absolute maximum, and here is the point where I have an absolute minimum. So that means if I was to write here, so the maximum here is x, I need x and y, right? So I'm going to do here, I have, this is my x is 2 and y is 5/2. Okay, and the minimum is, well, it's at this point here, so it's going to be -2 and -5/2. Okay, so that's, in this example, it's quite easy to find what are the absolute maximums and absolute minimums. Okay, so there's just two points which are the important for us in this case. Okay, so the next question. So again, you have this function and you're given the graph on this interval from -1 all the way through infinity. So that's the function. It looks like it's increasing all the time. It has this flat piece. So if we remember, we talked about, this is an example of a inflection point. So it's concave down, then it's concave up, and then it's concave down again. So there is another inflection point there. So what they want us to find is find the absolute maximum and absolute minimum of f and where they are attained. Okay, so again, the question is in terms of the x and y, but let's see, absolute maximum. So let's look at this function a little bit closer. So does it look like there is a point on the graph where you have a maximum? Well, there isn't, because look, I take any point, right? I go a little bit further, then the next point is going to be bigger. So the value of the function is going to be greater. So it's going to be get bigger, 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 bigger. So there is no point where I can find where the function is the biggest, because it looks like it's going to get bigger and bigger all the time. And this is an example of something which looks like it has an asymptote as, or it gets closer and closer to 1, but it never reaches 1. Okay, so in this example, what this means is that there is no maximum. So in this case, we can write here that the maximum does not exist. Okay, but the same thing is true for minimum, right? So if I take a point here, I take a little bit, point a little bit to the left, it's smaller. So there is always a smaller point. So there is no point which is the absolute smallest. So that means, again, there is no absolute minimum. So the answer in this case, again, does not exist. Okay, so that's, there is no absolute maximum and there is no absolute minimum. Okay. So, so these are the cases where you have a graph, so those are quite easy. So now, what if you don't have a graph? So, so let's look at these examples now. Okay, so you're given, okay, this one here, problem 3. Find the absolute maximum value and the absolute minimum value of the function. So, and if it doesn't exist, right, does not exist. So what do we need to do? First, of course, we have to find the critical points. So I'm going to find the critical points first. Okay, so what are the critical points? Those are the points where the derivative is equal to 0. So that's where I can have a local maximum or a local minimum, right? So I'm going to take the derivative. in this case is the derivative of this, and it's equal to negative 2x plus 4. Okay, so that's the derivative, and I'm gonna set it equal to 0 to find the critical points. So if I do that, I can solve. So I'm gonna get negative 2x plus 4 is equal to 0. So if I solve this equation, I'm going to, well, I can take the 2x to the other side of the equation, and I get that 2x is equal to 4. So that means that 2x is equal to 4. So that means x is equal to 2, right? So that's my critical point or critical number. And I want to find if I have a maximum or a minimum at that point. So let's take the easy way, which is the second derivative test. So let's take the second derivative, okay? So the second derivative of my function is the derivative of this expression here, and the derivative of the derivative, and so it's equal to negative 2x plus 4 prime. So it's just negative 2, right? And that's less than 0. Okay, so what does the second derivative test tells me? So the second derivative test tells me that I have so actually maybe I should say, so in particular the derivative, because the derivative at any point is a negative number, so in particular g double prime 2, so the second derivative at 2, which is equal to negative 2, is less than 0 again. So that means by the second derivative test I have a maximum. So g has a maximum, local maximum actually, at x equals 2. Okay, so it has a local maximum at that point. And so, well, we wanted to have the absolute maximum, but there is nothing else. There is just one critical point. And so to find the absolute maximum, we have to look at all the possible local maxima and choose basically the biggest one. So at that particular point, in this case, there is just one, so there is no choice. And because it's a maximum, because the second derivative is less than 0, it has to be an absolute maximum. So there is a absolute maximum at that particular point at x equals 2, because there is just one. Okay, there is one critical point. Okay, but what was the question? Find the absolute maximum value and absolute minimum value. So there is no absolute minimum in this case because there is just one critical point. So absolute maximum at this point is going to be x equals 2, and the value at that point is what we get if we plug x equals 2 in G. So I'm going to take absolute maximum value is G of 2, and that's equal to, well, I'm gonna plug it in this equation here, so it's going to be negative 2 squared plus 4 times 2 plus 8. So it's equal to, it's negative 4 plus 8 plus 8, so it's going to be negative 2, negative 4 plus 16, so that's 12. So that's my answer. Okay, so that's the absolute maximum value. And then the question is, what is the absolute minimum value? When in this case there is just one and it's a maximum, so in this case it does not exist. Okay, so we had to find the critical points. There is just one, and then we have to compare the values at the critical points and find out where this is the biggest. Okay, so let's do the next problem.
Professor,
Yes,
why does the minimum value does not exist?
because there is one critical point. So if there is one critical point and we know that it is a maximum. Why is it a maximum? It is because of the second derivative test. Second derivative tests tells me that if the second derivative at some point at that critical point is less than 0, then it has to be a maximum. Okay, so and there is just one, so we don't have a choice. There is just one point. So it has
Okay,
to be
so
either
in what
maximum and minimum, and we have to choose whether it is maximum and minimum, and in this case, because the second derivative is negative, it is a local maximum. Does that
okay,
make sense?
yeah, but in what case would we have a absolute minimum value?
Oh, we're gonna do next. So if you, for instance, in this case, if I had that the second derivative was positive,
Mm-hmm.
it would be an absolute minimum. We would plug it in and it would have been an absolute minimum. If there
Okay.
is if there is no critical point, if there is just one critical point, it's very easy, okay? Except when we're doing on a fixed interval, and the next example we're going to do that. So the next one is a little different, similar but a little different. So in this case, we have a graph. So we have a function and we have to find the absolute maximum minimum in a given interval. So in this case the picture looks like this. So we have, well, I don't know in this particular case how the graph looks like, but in general the graph may look like this, right? And say you're interested in the interval from here to here, right? So then your maximum and minimum are where are they attained? So in this case the minimum would be here, right? But the maximum would be not here, but it would be here, right? So the maximum of this function on this interval would be there. So if you're, so that means when you're doing with the fixed interval, closed interval here, right, like this, then you have to look at the, not only at the critical points where there is 3 critical points here, but also at the end points, this point and this point. So when you're doing an absolute maximum and absolute minimum on a fixed interval, closed interval, then you have to do also the endpoints to check the endpoints. So what's the idea here? We're going to find the critical points in the interval and then compare the function, the values of the function at those critical points and at the endpoints. Okay, so that's what we're going to do. So problem 4, this is my function. I have to find the absolute maximum and absolute minimum on this interval here. So that's what we're going to do. So first, again, we're going to find the critical points. So what is the critical? There is actually going to be 1 again in this example. So we're going to take the derivative and set it equal to 0. So I'm going to write f prime, right? It's going to be the derivative of this thing here. So I'm going to write it immediately. It's going to be negative 2x plus 6. So that's my derivative. And then I have to set it equal to 0. If I solve this, what do I have to plug here to get a 0? You have to plug x equals 3, right? So x is equal to 3. And that's my only critical point for this function, okay? However, note that this point here, x equals 3, is not in the interval, right? So we don't even have to worry about it at all, okay? If this point was inside this interval, then I would take the function, I would compare the values of the function at 3, at 5, and at 8. But what I do next, instead, I just compare the values of f. Actually, let me just do it like this. Compare the values of f at the points f at 5 and f8. Okay. Now, if these 3 was between 5 and 8, if I got a critical point which was between 5 and 8, I would also compare that, but I don't have to do it in this example. In the next example, I'm going to do that, but in this one, I don't. So what do I have to do? I have to calculate f5 and f8. So in this case, f5 is going to be negative 5 squared plus 6 times 5 plus 5. So I plug 5 inside my function instead of x here, and that's what I get. So if I do the calculation, that's going to be negative 25 plus 30 plus 5, right? So that's going to be negative 10. And so then I calculate f of 8.
Professor, I think it's positive 10.
Did I do something wrong?
It's negative 25 plus 30.
Oh, right. So it's going to be negative 20. It's plus 10, not minus 10, right? Okay. So, right. So then I do negative 8 squared plus 6 times 8 plus 5. So that's negative 64 plus 48 plus 5. So that's going to be what? I think it's, so if I do negative 64 plus 5, that's negative 59. So plus 48, that's negative 11, right? So those are the numbers. So I have these numbers. I think I didn't do any mistakes, but you should check. So, and then, so there's two things and I compare them. Which one's bigger? Well, 10 is bigger than negative 11, of course. So that means this one here is absolute maximum. And it's asking for absolute maximum value. So the maximum value. And this one here is absolute minimum value. Okay, now I could have had also a critical point inside the interval, and then I would have to compare the value of the function at that point as well, but I don't do it in this situation. Okay, so that's problem 4. Are there any questions about this problem? Okay, so let's do this one here. Very similar. Consider the function x to power 3 plus 3x squared minus 3 on this interval here. So now the interval is negative 3, 1. Find the derivative, critical numbers, absolute maximum value, and the absolute minimum value. Okay, so let's go step by step. So let's do the derivative first. So the derivative is the derivative of x to the third plus 3x squared minus 3. So that's equal to 3x squared plus 3 times 2x minus 0. So I'm not going to write that. So it's going to be, okay, so, well, I can leave the answer like this, right? So I can write it 3x squared plus 6x. Okay, so that's the derivative. Next, find the critical points. Okay, so the critical points, I need to set the g prime of x equal to 0. So that means I'm going to look at the solutions to 3x squared plus 6x equals to 0. So how do I solve this? Well, I can simplify this. I can factor out x, and also I can factor out 3. So I can write this as 3x, and then I have x from the first term remaining, and then 2 from the second term remaining. Okay? So my critical points are x equals 0, and also I have to have x plus 2 equals to 2 and to 0, which means that x is equal to what? Negative 2. Okay, so those are my critical points. X equals 0 and x equals negative 2. So let's see if they are in this interval. They're both in these intervals, right? So in that interval, negative 3, 1, right? 0 is there and negative 2 is there. So, so actually, let me check. Right. Okay. So, so I have 2 critical points. And now I'm going to find the absolute maximum value and absolute minimum value. What do I have to do? I have to calculate the values at this point. So next I'm going to compare f at 0, f at negative 2, and also at these points here at negative 3 and at 1. So I'm going to do f at negative 3 and f at 1. So there's 4 things I have to calculate, and the biggest one of these will be my absolute maximum, and the smallest one will be the absolute minimum. So I'm gonna do this. So so let's do f at 0. Is going to be 0 to power 3 plus 3 times 0 squared minus 3. So it's negative 3. F at negative 2 is going to be negative 2 to power 3 plus 3 times negative 2 squared minus 3. So that's equal to negative 8 plus 3 times 4 is 12 minus 3. So that's 4 minus 3. So that's going to be 1. Then I have f at negative 3. So it's going to be negative 3 to power 3 plus 3 times negative 3 squared minus 3. So that's going to be, well, this is negative 27 plus 27 minus 3. So that's negative 3. And then I have f at 1, which is 1 to power 3 plus 3 times 1 squared minus 3. So it's equal to 1. So I have these 4 numbers, negative 3, 1, negative 3, and then 1. Well, there's not many choices here, but that's what we have. There's just 2 numbers here. So I have absolute maximum value is going to be 1, right? So if they were different, I would choose the largest one, but in this case, these two are the same. So 1 and 1 are the same, so there is these two together. This is the absolute maximum value. And these two together, this is the absolute minimum value. Okay, so again, what's the idea? Find the critical point, so take the derivative, set it equal to 0, solve. So in this case, we got 2 points where the derivative was equal to 0. And then compare the values of the function at those critical points and at the endpoints of the interval. So in this case, 0, -2, -3, and 1, right? So this is 0 and -2, and then at -3 and 1. So, and then pick the largest one, and that would be your absolute maximum, and pick the smallest one, that would be your absolute minimum, okay, on that interval. So in this case, it turns out some of them are the same. No one said the absolute maximum can be only at one point. Okay, so next, let's do some examples where we apply all these things. So the next example is, actually this is very simple. So we have that the management of the producers of a famous hot sauce estimate that their profit in dollars from the daily production and sale of X cases is given by this function here. So that's the profit. What is the largest possible profit the producers can make in one day? So in this case, we have to find the absolute maximum of this function. This is the profit function. We have to find the largest possible profit. That means the absolute maximum. Okay, so let's do that. So what's the strategy? As always, we're going to take the derivative, set it equal to 0, and find the critical points first. Okay, so let's do that. So the critical points, right? So they satisfy, you take the derivative, and then you set it equal to 0. So in this case, it's going to be negative 0.0004 times, so the derivative of x to power 3 is going to be 3x squared plus 12, right? The derivative of x is 1, so I can write 1 minus 0, right? So it's just negative 0.0004 times 3x squared, or I can write it like this, 0.12 x squared plus 12. Okay, and then I need to set this equal to 0. Okay, so what do I get? If I solve, I get that if I move this to the other side, I get the equation, which is 0.0012 x squared is equal to 12, right? Okay, right? So if I move this to the other side, I get 12 is equal to 0.0012 x squared. So x squared is equal to 12 divided by 0.0012. Okay, so that means what? That means that this is equal to 10,000, right? There's 4 zeros here. 1, 2, 3, 4. Okay, so it's 10,000. So x squared is equal to 10,000. So that means x is equal to plus or minus 100, right? 100 squared is 10,000. So of course I'm only interested in, well, t is the number, x is the number of days, right? So I think, let's see, so on sale of xk, that's the number of cases you sell, so it has to be positive. Doesn't make sense for negative, so I have to choose x equals 100. So x equals 100. Okay, so so that's my x, that's the critical point. There is just one in the interval I'm interested in. So then let's take the second derivative and find out whether I have a local maximum at that point or local minimum. Note, in this case, they're not giving me the interval, right? I know it has to be at least 0 cases, so start 0, but how large it can be, I don't know. So there is no endpoint, so I have to do the second derivative test to find out whether this is maximum or minimum. So let's do that. So let's take the second derivative. So let's do the second derivative test. So I'm going to take the second derivative of p, so it's going to be p double prime x is equal to what? Well, what is my derivative? Here is my derivative. So if I take the derivative of that, it's going to be minus 0.012, one more zero, x squared, so the derivative of that is 2x, right? So 2x. So that's my derivative, because the derivative of 12, this 12 here, is going to be 0. So the whole thing is negative 0.0024x, okay? And if I plug x equals 100, it's going to be a negative number. Minus 0.0024 times 100, whatever it is, it's a negative number. So that means I have a local maximum at that point, x equals 100. Okay, so I have a local maximum at that point, and since there is no other point, it's actually, so there is just one critical point, there is no end points, or if you want, you consider 0 to be an end point, but at 0 you're going to be having a negative profit anyway. So all you have to do is to figure out, so this is in reality, so it's an absolute maximum, since no other critical points, it's also an absolute maximum. Okay, so it's an absolute maximum again because there is no other critical points. Okay, so all we have to do is to figure out the largest possible profit. All we have to do is plug 100 instead of x in this formula. So we write that, so largest profit is P of 100. So which is equal to so negative 0.0004 times 100 to power 3, right? So that plus 12 times 100 minus 20. So if you do the calculation, you're going to get some number. So I think you're going to get maybe 400 plus, right? So negative right, so negative 400 plus 1200 minus 20. So in this case, it's going to be 780. Okay. So that's your absolute maximum. Okay. Any questions about this problem? So again, this was just so we had to find the largest value of this function. So the way we did find the critical points. We took out of the critical points the one which makes sense. In this case, it's x equals 100. And then because there is no other critical points in the interval we're interested in, and there is no endpoints because there is no limit as how many things you can make, the number of items you can produce, you only have one critical point in that interval. You compare it to at that point, and what you get is that this is the absolute maximum, especially because you have the second derivative test telling you that it's also a local maximum. So the local maximum is an absolute maximum if there is no other critical points. Okay. So okay, so let's do the next problem. So this is more of what the optimization problems are like. So it's quite possible you have an example like this either on the final or on the midterm. So again, what is the question? Find the dimension of a rectangle with a perimeter of 80 feet that has the largest possible area. So so we're going to look at the rectangle, and you don't know what the sides are, so but what you know is that the sum of the sides, so this side, so the sum of this side, this side, this side, and this side together is 80 feet. Now you have to construct it in such a way that the area inside is the biggest. Okay, so for instance, you have a fixed amount of money on a fence. You want to get the biggest amount of your yard, the biggest area yard you can get with the same amount of the fence. And then it's clear that if you take the extreme situations when there's one side is very small and the other one is very big, you're going to get not the biggest possible thing. Okay, so how do you do this? Well, let's actually make some notation. So let's make one of the sides, we will call it x. The other side, we will call it y. Okay, so what is the condition telling us? Well, it says that the perimeter of this rectangle is 80 feet. What is the perimeter? It's the sum of all sides. So it's going to be x plus y. But then there is another x here, right? This one's x2. And the top one is y2. So it's going to be plus x plus y. That's my perimeter. So it's equal to 80 feet. Okay. Okay. So let's actually simplify a little bit. So this is equal to 2x plus 2y equals 80. Okay. Well, what's the question? The question is find the largest possible area. And what is the area? Area is x times y. Right? So we know that 2x plus 2y is a number, fixed number, and we want to find the largest possible area. Okay, so if this is 80, so imagine that if I took my x really small, right, if x was this big and y was almost like, well, how large can y be? Well, if there's going to be this one's y, this one y, and then the whole thing is 80, so this one is, each one of them is at most 40, right? So if this is a tiny bit and this is very close to 40, then the area inside is going to be very small, so it's almost zero. Similarly, if y is small and x is large, you have a very small area. So somewhere in between, you have the largest possible area. So we want to find that. Okay, so we want to find the maximum of this function here. However, the problem is that this is not a function of one variable, it's a function of x and y. So what we do, we express y in terms of x. How do we do that? Well, we use this equality here. From here, we can solve for y, right? Solve for y. So I'm going to write that, actually simplify. I have x plus y times 2 is 80. So x plus y is 40, dividing both sides. So that means y is equal to 40 minus x. Okay, so if I plug that into this equation here, I'm going to get that the area is equal to x times 40 minus x. Okay, so then that's my function, and I want to find, actually, let me simplify it further. I'm going, it's easier to do it like this, 40x minus x squared. Okay, so I want to find the maximum of this function here. Okay, how do I do that? I have to find the derivative, set it equal to 0, and solve. Well, not what this is just a parabola, right? And because I have a negative sign, my leading coefficient is -1, so that means it's a parabola with branches going down. So it has a 1 maximum. So to find that point, we just set the derivative equal to 0. So let's find a prime. So I'm going to write that a prime is equal to 40 minus 2x. Okay, so then I have to set it equal to 0. So if I set this equal to 0, and again I move 2x to the other side, I'm going to get what? 40 is equal to 2x, so that means x is equal to 20. So that's my critical point. To make sure that it's a maximum, we already know it, but just let me show. So we use the second derivative test again. If I do the second derivative of this function here, of the first derivative, that's going to be equal to 0 minus 2, right? And that's less than 0. It's equal to -2. It's less than 0, so you have a local maximum. Okay, and I mean, we are on a fixed interval here, because what is my x and y? How large and small can they be? Well, those are lengths, so they cannot be smaller than 0, right? So because they also cannot be greater than, let's do 80, okay, because their sum is 80, so each of them cannot be greater than 80. So I have that my interval, in fact, it's 40. I don't have to do all the way 80, right? Because y here is less than 40, right? 40 minus x. See, x plus y is 40, so each of them is at most 40. So then I'm looking at the interval 0, 40. Okay, at those points at 0 and 40, if I plug 0 or 40 into this problem here, into the area, what do I get? Or this one here. If I plug either 0, I'll get a 0, right? If I get a 40, I get the 0 here, so the area is 40. So it's a function which is 0 at the endpoints, and it has a maximum at the point 20, local maximum. Well, it has to be an absolute maximum, right? So we have absolute maximum is at 20. So I'm going to write here not local maximum, but absolute maximum. Okay. Well, now all I have to do is figure out, just plug this number 20 into my formula for A. So to find the largest area. So I'm now made sure that it was the largest area. So all I have to do is to plug that number in. So A of 20 is going to be equal to, well, I'm going to plug it into this formula or this formula, doesn't matter. So it's going, if I plug it into here, I'm going to get 20 times 40 minus 20. So that's 20 times 20, which is 400. So that's my maximal possible area. And it happens where the x is equal to y and is equal to, actually it needed to, you didn't need to find the largest possible area, you needed to find the dimensions. So, well, the dimensions are x equals 20 and y is also equal to 20. Y is equal to 40 minus 20, which is 20. So the largest area is attained for a square. So the square has the largest possible area. Okay? Any questions? Okay, so I'm going to so we still have 15 minutes. So let's see, we have some more problems. I'm going to do the next one similarly. So, okay, let's do this one here. So find the dimensions of a rectangle of a given area that has the smallest possible perimeter. So now we're assuming that we have rectangles, and now I know that they have the fixed area. So the area is given here. Area is actually given and it's equal to 225 feet squared. So all I have to do now to find out when I have the smallest possible perimeter. So like in the last problem, I have that if this is x, this is y, then the area is equal to x times y, and the perimeter is equal to x plus y plus x plus y. So it's going to be 2x plus 2y. Okay, so it's going to be 2 times x plus y. Okay, so now what do I know? That I know that the area of the rectangle is given to me. It's equal to 225 feet squared. So I want to find for which values the perimeter is the smallest. Okay, but again, perimeter now is a function of two variables. So there is x and there is y. So I want it to be a function of one variable. How do I do that? Well, I solve for y from here and plug it in here. So let's do that. So it's going to be y is equal to 225 divided by x, right? Divide both sides of this equation by x. So move this x under 225. And then I'm going to plug that into here. So it's going to be P is equal to 2 times x plus 225 divided by x. Okay, and I want to find where does this function has attains its maximum. Okay, actually find the dimensions. So find the x and y where it is it has the smallest possible parameter. So for that I have to take the derivative. So it's going to be the derivative is going to be p prime. That's going to be 2 times the derivative of x is 1, and then I have the derivative of 225 over x, so it's going to be 225, and the derivative of 1 over x is, well, it's x to the power negative 1, so it's negative 1 over x squared. So, or if you want, so x squared, but there is also a negative sign, so I'm going to write it here. So this plus becomes a negative sign here, okay? And now we need to set this equal to 0 and solve. Well, if we set it equal to 0, what that means is 1 minus 225 over x squared is equal to 0. So that means 1 is equal to, so I'm going to move 225x squared to the other side. So I'm going to get this is equal to that. So that means x squared is equal to 225. So why is it a negative sign? That's because 1 over x prime, well, that's x to the power negative 1. So that's negative 1 times x to the power negative 2. So it's negative 1 over x squared. Does that make sense? So that negative here is the same as this negative here. Okay, so so that means x, well, what is the number whose square is 225? I believe it's 15, right? So the answer is plus or minus 15, and as usual, negative 15 doesn't make sense because it's about the length, so we're just doing x equals 15, okay? So that's the only one which makes sense in this example. Okay, so now if I take 15, so again, just like in the previous case, we can take the second derivative and see that it's less than 0 at that point, but it's easy. So let's actually I think let's do the, well, if we want it the smallest, then we want it to be positive. So let's do the second derivative test. So p double prime is going to be the derivative of this expression here. So that's going to be equal to 2 times, well, the derivative of 1 is not going to be there, so it's going to be negative 225 divided by, okay, so the derivative of x squared, 1 over x squared is, well, that's x to power negative 2, right? So that's just negative 2 times x to negative 3. So if you do it like this, then you will have that this is equal to negative 225 times this thing here, okay? Negative 2 times x to negative 3. So it's going to be positive, right? It's going to be 2 times 225 times 2 times x to the power negative 3. Okay, so it's something. So now if I plug 15, so if I plug 15 here, that's the critical point I got. It's going to be what? Positive. It's going to be 2 times 225 times 2 times 15 to the power negative 3. So all positive numbers. So this is positive. So you have a local minimum. That's the second derivative test. So we have a local minimum. And again, because there is no other possibilities, no other critical points, or if you want, you can look at the points where the largest and smallest points of x, what was the largest, x was the smallest, okay? Then you will see that this is going to be absolute minimum as well. So in your exams, you don't have to say why it is an absolute minimum if it is a local minimum in this kind of examples, okay? So therefore, we have that the smallest possible perimeter is obtained for x equals 15, and if I choose, if I plug y into this formula here, 225 over x, then I also get that y is also 15, right? So then absolute minimum is for x equals 15 and y equals 225 divided by 15, which is also 15. So that's my answer. So the dimensions are x equals 15 and y equals 15. So those are the dimensions where I have the smallest possible perimeter. Okay. Okay, so I don't think I have time to finish the last two problems, but if you guys have any questions, you can ask me now, and I'm gonna let you go. After that, I'm gonna go over the solutions for this, and when I post it, so that you have the solutions for all the problems. Okay. Do you guys have any questions? You're welcome to stay, of course. If you don't have classes and if you have questions, I'll be answering them as well. Okay.
Professor,
Yes.
when is the next test?
It's going to be in 1 week. I'll be sending you a practice test today. And then we will go over the practice test on Tuesday. And then on Thursday, you will have the practice test. No, the actual test.
So on Thursday next week?
Yes.
Okay. Thank you.
Mm-hmm. Yeah, so I will be sending the instructions on how the test will be taking, but it will be just by, I will be just doing the, I'll send you the test, you will fill out and then send it back to me. Okay, if there's no other questions, yes, you can take the pics. There's actually an app which is so that you can take, you can scan with the phone. So it's very convenient. So you can take the pictures and make one single file. I'll send links to that as well. Yeah, thanks. You too.